Okay, everybody, so we're going to pick up, I'm going to do several little lectures here so it's not so overwhelming, but we're going to pick up right now on the idea of interest, remember? And we did that example in class this morning about interest and compounded interest. So just to show you the difference, okay, if you took out a loan for $100 at 9% interest, okay, and it was compounded at 9%, and we'll just say our periods are years. After 20 years simple interest, you would owe $280. At compounding interest, remember paying interest on the interest, it's $560.44. So that is a lot of money. Okay, there's a big difference there. So when we talk about this compounding, so far to date, we've only been talking about per year, okay? So remember in our thoughts here, P is a present amount, okay? And for right now, that means today. T, when our time is 0. F is our future amount. Some periods in the future. N is the number of compounding periods. Now remember, that does not necessarily mean years. And that's what we're going to talk about right here for this brief time. N is the number of compoundings per year, and I is the interest rate per compounding period. Okay? Those are the things. And remember in class, we went through real quickly, and you can read in the lecture notes, we remember that our formula is our future amount is our present amount times 1 plus the interest rate to the number of periods. And we derive that. And from that, we can just do some algebra and say our present amount is the future times 1 plus I to the negative n. But right now, we're going to look at this. So let's say in this example over here, I'm going to have $100, 12% for 1 year. If my compounding is annual, that means I'm going to get 2 compounding periods. I'm sorry, what am I saying? I'm going to get 1 compounding period in 1 year. So the interest rate per period, interest rate per year, is 12%. So my F is going to be 100 times 1 plus 0.12 raised to the 1, which is $112. Now we say, no, our loan is semi-annually compounded. Well, semi-annually means 2 periods per year. Interest rate is always given percent per year, and then it says compounded. Okay, so go out on the web or go to your bank. Interest rates are usually given in percent per year compounded, I don't know why I did that, compounded something. So here, right here, down here, it's compounded semi-annually. So our interest rate per period would be 12% divided by 2. So every period we're paying 6%. So think about that. So in 6 months, I owe $106, and in another 6 months, I owe 6% of 106. So if I put in my formula, I would have 100 times 1 plus 0.06 squared, because I'm getting 6% every 6 months, twice a year. Well, now that is $112.36. So look, I just gave the bank $36 more. Quarterly is by 4. So 12% compounded quarterly is 12% divided by 4. It's 3% per quarter. And this would be 6% per semi. So now again, now think about it. It's After 4 months, I owe 103 bucks. After another 4 months, after another 3 months, quarterly is divided by 4, 3 months. After 3 months, I owe 103. After 6, I owe 3% on 103. After 9, I owe 3% on my 103 plus my next set of interest. So I keep building. So this might get a little expensive here. 100 times 1 plus 0.03. And there are 4 compounding periods in a year. All of a sudden, it's 112.55. I'm not doing anything. It's still only for a year, right? It's just how they're compounding. Monthly, I get 12. So 12% divided by 12 is 1% per month. So it's 100 times 1 plus 0.01 to the 12th is 112.68. Now you think, wow, hey, Krista, it's $68, 68 cents. What if it was a house for $112,000? I'm now spending an extra $680 in 1 year. That's only 1 year. Think over 30 years. So this power of compounding is really, really important that you understand. So the big thing here is N is the number of compounding periods, I is the interest rate per compounding period, and P is the present amount of money. Okay? So I hope that that is making some sense here. So I'm trying to see if I can get no, we'll do some examples in a minute. So the next thing I want to talk about here is something called equivalence. Now, you got to read this definition. It is when an organization is indifferent as to whether they get money now or the assurance that I'm going to get money into the future. Okay? This only holds true for a certain interest rate, and that you can do all of this. So think about this, okay? One way to repay a loan, and you're just going to have to believe that I'm saying the right thing, okay? One way to repay a loan, a $5,000 loan over 5 years at 8%. One way is to pay all of the divided 5,000 into 5 and pay the interest, okay? So I could pay it this way. One way is to pay just the interest each year and pay the end. One way is to figure out what would be my equal payments, or one way is a lump sum payment. Equivalence states the bank doesn't care which way to do it, because here the bank's going to take the $1,400 and reinvest it somewhere else for that interest rate. In year 2, it'll take the $1,320 and reinvest. Here, it'll take the interest and reinvest it somewhere else. Here, it's going to take that equal amount, and here it doesn't need to reinvest anything because it keeps making interest. So that's the theory of equivalence. Okay? Due to equivalence, that's how we can compare alternatives when we don't care, as long as we're getting our interest rate over the interest periods. Okay, so that is the end of the first lesson, 3 lessons in Unit 3. So that's the end of the first lesson, and I'm going to stop here.